Okay, so I want you to picture something for me. Let's say, just for a second, you win the lottery. I'm not talking about, a few $1,000s. I'm talking massive buy an island kind of money.
I'm listening. This is a good start.
And you decide, with all this cash, to go out and buy the most expensive, most ridiculous, high-performance hypercar on the planet.
Okay, so like a Koenigsegg or something.
Exactly. Something with millions of moving parts, sophisticated chemical sensors, it's got self-repair capabilities, an onboard computer that makes NASA's setup look like, I don't know, an abacus.
Right. A beautiful, incredibly complex machine.
So you buy this thing, it gets delivered to your driveway, it's gleaming, you can't believe it's yours. And then you realize something. There's no manual in the glove box.
Oh, no.
No instructions. You don't know what kind of fuel it takes. You have no idea how often you're supposed to change the oil. You don't even know what half the buttons on the dashboard actually do. What would you do?
That is a recipe for a very, very expensive explosion. You wouldn't just, try to run a Formula One car on regular diesel and just hope for the best.
You would be terrified to even touch it, right? But here's the kicker. And this is the thought that honestly kept me up last night while I was reading through today's material. We all own that machine.
We do.
It's our body. And for the most part, none of us got the manual. We've just been pushing buttons for 20, 30, 40 years, essentially guessing and just hoping we don't break anything critical.
And honestly, I think most of us are breaking things. We just don't realize it until the check engine light finally comes on, which for us looks like a disease or chronic pain or just feeling exhausted all the time.
Right. So today's a bit different. We're not just exploring a single topic. We are, in a way, trying to write that missing manual. We're doing a deep dive into a collection of materials that claim to be exactly that. The owner's manual you never got. It's a biological guide to human optimization.
And I have to say, looking at the sources we've pulled together for this is not the usual drink more water and think positive thoughts kind of fluff. This is dense.
It's really dense.
It's a no-fluff, high-density guide to the actual mechanics of being a human. I mean, it covers everything from the biochemistry of sleep and breathing to, and this is wild, hidden environmental toxins in your wallet.
I know, the receipt thing blew my mind, but also it goes into the structural integrity of your spine, your feet, your eyes. It's a lot.
Well, it is.
I was reading through this stack of notes, and I swear about every 5 minutes, I just had this sinking feeling of, oh no, I have been doing this completely wrong my entire life. I feel like I owe my liver and my spine a formal apology.
That's a very common reaction, I think, when you start peeling back the layers of convenience that we all live in. The central theme that we're really going to explore today is this fundamental conflict between what we'll call biological truth and modern convenience.
Okay, explain that a bit more.
Well, we've built a world that is incredibly comfortable, right? It's climate controlled, it's lit up 24/7. We have endless food available at our fingertips. But our biology, our software, it requires stress.
That sounds wrong. We're supposed to avoid stress, aren't we?
We avoid chronic mental stress, yes. But our bodies require acute physical stressors like exercise, hunger, temperature changes to function properly. So when our comfortable environment fights our biology, we get dysfunction, we get inflammation, we get fatigue, and we get what we just kind of lazily call aging.
So the mission today is simple, but also kind of terrifying. We're going to try and identify the fatal errors that we're all running in our daily software, and we're going to try to patch them with scientifically grounded protocols. We've got a lot to cover from the moment you wake up to how you sleep and pretty much everything in between.
It seems like we should probably start with the absolute foundation of everything, the thing that sets the rhythm for the entire machine. The master clock.
Let's do it. So we're talking about circadian biology. And I think for most people, myself included, sleep is just, checking out. You turn the lights off, you lie down, you recharge the battery like it's an iPhone, and then you wake up. But this guide says that that way of thinking is a fatal error in itself.
It absolutely is. Viewing sleep as just a passive recharge period is precisely why so many of us struggle with it. Sleep is not passive at all. It's an incredibly active, very complex metabolic process. You have a region in your hypothalamus. It's called the suprachiasmatic nucleus.
The SCN sounds like a villain in a Marvel movie. Beware the SCN.
Well, it practically is if you mistreat it. Think of the SCN as the conductor of a massive biological orchestra. It controls your hormones, your digestion, your body temperature, your cognitive repair processes, everything.
Okay, so it's the boss.
It's the boss. But here's the catch. The boss doesn't have a watch. It can't tell time. It is gated entirely and exclusively by one thing,
Mm.
light.
And this is where we get into the light hygiene error, right? Because I feel like everyone sort of knows that screens are bad at night, but I don't think we really understand why or how bad. We just think it's about, being distracted.
Exactly. It's much deeper than distraction. It comes down to a very specific biological mechanism. You have these specialized cells in your eyes called melanopsin ganglion cells.
Okay, that's a mouthful.
It is, but they're important. These aren't the rods and cones that see images, color, and shape. They are literally just cells that sense the brightness and the color temperature of light. That's their only job.
So they're like a little light meter in your
A
eyeball.
perfect analogy.
Hmm.
And they send a direct signal to the SCN, the conductor. So if bright blue spectrum light hits those cells in the morning, the SCN says, okay, sunrise, time to release cortisol, wake up the digestive system, get the body moving.
Which sounds good. We want that in the morning.
We absolutely want that at 7 a.m. We do not want that signal blasting our brain at 10 p.m. But if that same artificial light from a phone or a TV hits those cells at night, it sends the exact same, it's morning signal. And that signal suppresses a hormone called melatonin.
And melatonin is the sleepy chemical, right? I take a gummy to get drowsy.
That's what most people think, and that's the surface level effect. But it's so much more than that. Melatonin is actually one of the most potent antioxidants in the human body. It's one of the very few that can easily cross the blood-brain barrier.
What does it do in the brain?
It scavenges free radicals. It's basically the brain's nighttime cleaning crew. It cleans up the metabolic trash that accumulated during the day. So if you suppress your melatonin by looking at a screen between 10 p.m. and 4 a.m., you're not just losing sleep.
Well, it might do it.
You're losing brain repair. You are essentially leaving the cleaning crew locked outside the building while the trash piles up inside, night after night.
That is a horrifying thought. So by scrolling on my phone in bed at midnight, I'm not just staying awake, I'm actively preventing my brain from cleaning itself out.
You are actively inducing systemic inflammation in your own brain. It's that direct.
Wow. The source material gets very specific about the wavelengths here. It's not just light, it mentions blue light, specifically in the 400 to 490 nanometer range. Why that specific spectrum?
Because that's the spectrum of the midday sun. Evolutionarily, when our eyes see a heavy dose of that blue-green light, it means it's noon. It means be alert, hunt, gather, be productive. That specific wavelength has been shown to suppress melatonin production twice as effectively as other wavelengths of light.
Okay, so this is a serious problem. What's the fix? The guide seems to have a two-part solution.
It does. First, you have to properly start the timer in the morning. The guide is very clear on this. You need to view sunlight, actual direct sunlight, not through a window if possible, for 10 to 30 minutes. And it has to be within an hour of waking up.
Wait, hang on. Why not through a window? I've got big windows in my bedroom. I get lots of light.
It's not the same. Modern windows have UV coatings and other filters. They block a significant portion of the specific spectrums your retinas need to trigger that healthy morning cortisol spike. It's like trying to get a suntan through your car's windshield. It just doesn't work very well. You need the raw photons hitting the retina.
And that morning light, that sets the timer for the evening.
It sets the timer for the melatonin release 12 to 14 hours later. It's like winding up a grandfather clock. You have to do it at the same time every day to keep the rhythm.
Okay, so get outside immediately upon waking. That's step one. What about the evening? I mean, I can't just live in a dark cave after the sun goes down.
You don't have to live in a cave, but you absolutely have to curate your light environment. This means using software on all of your devices that aggressively shifts the colors to red or orange. Things like f.lux or the built-in night shift.
And you mean really red, right? Not just slightly less blue.
Your laptop screen should look like a pumpkin. If it still looks white, it's too blue. But it's not just screens. You have to dim your overhead lights. Overhead lights are a huge problem.
Why overhead specifically?
Because they mimic the sun's position. Our biology is ancient. It assumes that bright light coming from above is the sun. Light coming from below or the side, like a fireplace, a candle, or a floor lamp, is interpreted as being much safer and less disruptive.
Okay, so morning sun to wind the clock. Evening red light from lamps, not from the ceiling, to protect the brain's cleaning crew.
Precisely.
Now let's talk about the fuel we use to force ourselves awake when we inevitably mess all that up. Caffeine, this section.
Oh.
this section honestly ruined my afternoon. I love my 3 p.m. coffee pick-me-up.
I know. This is a tough one for a lot of people to swallow, but it really just comes down to unyielding biological math. The half-life of caffeine is, on average, about 5 to 7 hours.
Can you break that down? Because I think when people hear half-life, they think of, nuclear waste, not their afternoon latte.
It's the same exact concept. It means it's the time it takes for your body to process and eliminate half of the substance. So let's do the math. If you drink a 200 milligram coffee, which is a pretty standard strong coffee, at 3:00 p.m.,
Okay, I'm with you.
5 hours later, at 8:00 p.m., you haven't processed all of it. You still have 100 milligrams of active caffeine circulating in your system.
Right. Pack is gone.
And then by 1 a.m.,
Ah.
5 hours after that, you might still have 50 milligrams active in your blood. That's the equivalent of taking a shot of espresso and then immediately trying to go to bed.
But, and I hear this all the time from friends, people say, oh, I'm different. I can drink an espresso right after dinner and fall asleep 5 minutes later. I'm fine.
They are unconscious,
Hmm.
but they are not getting restorative sleep. There is a huge, huge difference. Caffeine's primary mechanism is to block adenosine receptors in your brain.
What's adenosine?
Think of adenosine as sleep pressure. It builds up all day long. The longer you're awake, the more adenosine you have. It's like a car trying to park in a specific spot in your brain. When the car parks, you feel sleepy. Caffeine is like putting a big orange traffic cone in that parking spot. The car sleepiness can't park. So even if you eventually pass out from sheer exhaustion, because those receptors are blocked by the caffeine cone, you are not getting into proper deep wave sleep.
And that's the physically restorative part of sleep.
Exactly. That's where you repair muscle tissue, release growth hormone, and your arteries get scrubbed clean.
Yeah.
If you compromise that stage of sleep with caffeine, you will wake up physically unrecovered, even if you were asleep for a full 8 hours. You feel groggy, and you reach for more coffee.
It's a vicious cycle, so the guide suggests a really strict cutoff time.
The ideal is a 10 to 12-hour window before your intended bedtime. So if you want to be asleep by 11 p.m., you really shouldn't have any caffeine afternoon. Ideally, 11 a.m.
That is brutal. But the logic is sound. Okay, so we've got light and caffeine. The third pillar of sleep mentioned here is thermal regulation. Now, I have always liked a cozy, warm bedroom. I want to be toasty. Apparently, that is also a huge mistake.
It is a major one. Biologically, your core body temperature must drop by about 1 to 2 degrees Fahrenheit, or about 1 degree Celsius, to both initiate sleep and stay asleep. If your room is 70 degrees or higher, that's about 21 Celsius, your body physically struggles to dump that heat.
So what's the ideal target temperature?
The science is pretty clear on this. The optimal ambient range for sleep is between 15 and 19 degrees Celsius, which is 60 to 67 degrees Fahrenheit.
60 degrees. That is freezing. I'm going to be shivering all night.
Well, see, here's the nuance. You could use blankets. In fact, heavy blankets are great, but the air that you are breathing needs to be cool.
Why the air specifically?
Your lungs are a massive heat exchanger. When you breathe in cool air, it cools the blood circulating through your lungs, and that blood then circulates throughout your body and cools your core from the inside out.
Ah, okay. So I can be buried under a heavy duvet, warm as can be, but the room itself needs to feel like an icebox.
That's the perfect setup. And if you're one of those people who gets cold feet, which can keep you awake, the guide says to wear socks.
Socks to bed.
Yes. Warm hands and feet actually help you sleep. It causes something called vasodilation. The blood vessels in your extremities open up, which brings blood to the surface of your skin and helps radiate heat out of your core, which is exactly what you want. So wear socks, use blankets, but keep that thermostat turned way down.
Okay. Cool room, dark evenings, bright mornings, and no afternoon coffee. That is the new sleep protocol. Now, let's move to something we do even more often than we sleep. Breathing? You would think this of all things would be automatic. I mean, if I wasn't breathing, I'd be dead. How can I possibly be doing it wrong?
You breathe about 20,000, maybe 25,000 times a day.
Mm-hmm.
And the source material argues that the vast majority of us are doing it incorrectly and in a way that keeps us in a chronic state of low-level stress.
This brings us to the section on the chemistry of oxygen. And this part was just fascinating to me because it completely flips the script on why we breathe. I always assumed I need more oxygen, so I should take a big breath in. But the guide talks about something called the Bohr effect, and it says we actually need CO2. That seems backward.
It does seem backward, but the Bohr effect is absolutely crucial, and it's probably the most misunderstood part of respiration. We tend to think of carbon dioxide, CO2, as just a waste product, trash that we have to exhale. But biologically, CO2 is the key that unlocks the door for oxygen to get into our cells.
Okay, you have to explain that analogy. How does that work?
So think of your red blood cells, the hemoglobin, as a taxi driver. And oxygen is the passenger. The taxi driver picks up the oxygen passenger in the lungs. But this taxi driver is very, very stingy. He absolutely refuses to let the passenger out of the car unless he gets paid.
And I'm guessing the CO2 is the payment?
CO2 is the cash. When the blood reaches a muscle or an organ that's working hard and needs oxygen, there's a lot of CO2 in that tissue. The hemoglobin sees the CO2, accepts the payment, and only then does it release the oxygen passenger into the tissue where it's needed.
So if I don't have enough CO2 in my blood, let's say because I'm breathing too fast and blowing it all off.
The taxi driver keeps the door locked. The oxygen stays trapped in your blood, unable to get out. You can have 100% blood oxygen saturation level. You put the little clip on your finger and the doctor says your levels are great, but your actual tissues can be suffocating. This is what happens when you chronically overbreathe. You blow off too much CO2, and your brain and muscles literally starve for oxygen.
And this leads directly to the mouth breathing villain. I honestly didn't realize how bad mouth breathing was until I read this. I definitely catch myself doing it when I'm concentrating or feeling stressed out.
It is, from a biological standpoint, a disaster. First, the obvious. You completely bypass the incredible filtration system of your nose, so you're just inhaling dust, pollen, and pathogens directly into your lungs. But much more importantly, your sinuses produce a critical molecule called nitric oxide, or NO.
That's not nitrous oxide, right? The stuff from the dentist?
No, not at all. Nitric oxide is a potent vasodilator, which means it expands your blood vessels and your airways.
Yeah.
When you breathe through your nose, you pull that NO down into your lungs. And that dose of nitric oxide has been shown to increase your body's oxygen uptake efficiency by as much as 10 to 18%. It also lowers your blood pressure almost instantly.
And when you breathe through your mouth, you get how much of that?
Zero. None. Instead, you get vasoconstriction, higher blood pressure, and much poorer sleep quality.
The fix for this during the daytime seems easy enough. Just keep your mouth shut. The guide says to rest your tongue on the roof of your mouth, but the nighttime fix, this is the one that might freak people out a little bit. Mouth taping.
It does sound extreme, I'll grant you that. When people first hear about it, they think of a hostage situation or something. But it is remarkably effective. The recommendation is to use a small strip of gentle micropore tape, the kind of paper or surgical tape you can get at any pharmacy, definitely not duct tape, and place it vertically across the center of your lips while you sleep.
So the goal is just to physically force the jaw to stay shut.
It's more about creating a gentle somatic signal to your brain. You don't need to seal your mouth airtight like a jar. Just that small strip in the center is enough of a reminder to your subconscious brain, okay, the mouth is supposed to be closed. It forces you into nasal breathing all night long.
And the benefits are?
What? It can prevent snoring. It's a huge help for mild sleep apnea. And because you aren't constantly blowing off all your CO2, it drastically improves your REM sleep quality.
I have to be honest, I tried this last night after reading the guide. The first night, I woke up and the tape was stuck to my forehead. I clearly ripped it off in my sleep.
That's totally standard. It takes about 3 or 4 nights for your brain to get used to the new pattern. But once you do, the difference in sleep quality is profound. You don't wake up with that horrible, dry, sandpaper mouth anymore. And you wake up feeling much more refreshed because your oxygen delivery was more efficient all night.
I suppose the hardest part is just explaining to your partner why you're taping your face shut right before you go to bed.
It is not the sexiest biohack, I will admit that. But it absolutely works.
Okay, so tape the mouth at night. But we also have to address the rate at which we're breathing. The source material says modern humans breathe somewhere between 12 and 18 times a minute. But the optimal rate is closer to 6. Are we just hyperventilating constantly?
Basically, yes. We live in a state of chronic low-level panic. Rapid, shallow breathing is a direct signal to the vagus nerve that you are under threat. It keeps your cortisol baseline elevated all day long. The fix, according to the guide, is to practice air hunger.
That sounds incredibly unpleasant.
It's just a practice. You intentionally slow your breathing down, light, slow, deep breaths, until you feel a slight, tolerable urge to breathe more. That sensation, that air hunger, is a signal that your CO2 levels are rising.
And we want that because of the taxi driver analogy.
Exactly. That rising CO2 means that oxygen delivery to your cells is actually becoming more efficient, not less. By doing this, you're training your body's chemoreceptors to tolerate higher levels of CO2, which makes you far more resilient to physical and psychological stress.
So the goal isn't to never feel the need for a breath, it's to become comfortable with that feeling.
That's it. Perfectly.
Okay, let's shift gears and head down to the engine room. Metabolism. This next section is titled The Metabolic Engine, and it introduces this concept of metabolic inflexibility. What exactly does that mean?
It's a term that refers to the modern inability of our bodies to efficiently switch between burning glucose, which is sugar from food, and burning stored body fat. Evolutionarily, we are hybrid engines. We should be able to run on the fuel we just ate, and when that's gone, seamlessly switch over to burning our own onboard battery packs.
But most people can't do that.
Most people are stuck burning glucose 24/7. They've completely lost the metabolic machinery to access their own stored energy. They are metabolically inflexible.
And the main culprit here is what the guide calls the grazing error. I have been told so many times over the years to eat 6 small meals a day to keep my metabolism up, soak in the metabolic fire, right? This guide says that's complete and utter nonsense.
It's a complete misunderstanding of how the hormone insulin works. Every single time you eat, especially carbohydrates or protein, your pancreas releases insulin. Insulin is a storage hormone. Think of insulin as a guard that locks the doors to your fat cells.
Okay.
When insulin is high, the process of lipolysis, which is the scientific term for fat burning, is chemically blocked. It is physically impossible for your body to burn stored fat when insulin is present in the bloodstream.
So I'm snacking every 2 hours, even if it's healthy snacks like almonds or an apple.
Your insulin level never has a chance to return to its baseline. You are keeping yourself in storage mode all day long. You never give your body the all-clear signal to unlock the fat cells and start burning that stored fuel. Over time, this leads to insulin resistance. Your cells stop listening to this signal because the doorbell has been ringing constantly for years.
The fix suggested in the material is time-restricted feeding, or TRF.
Right. The idea is to eat all of your meals within a confined window, say 8 or 10 hours, and fast for the remaining 14 or 16 hours of the day. But critically, you have to allow at least 4 hours between your meals within that window. No snacks.
Why is the 4-hour gap so important?
Because of the gut's cleaning crew. There's a mechanism in your digestive system called the migrating motor complex, or MMC. It's a series of powerful, wave-like muscular contractions that sweeps through your intestines to push undigested food particles and bacteria down into the colon. It's like the janitorial staff that comes in at night to clean up.
I see.
But here's the crucial part. The MMC only turns on if you haven't eaten for about 90 minutes to 2 hours. And the second you eat anything, even a single bite of food, it shuts off immediately. The body says, oh, more food is coming. Stop the cleaning process.
So if I'm grazing all day, the janitor never shows up to work.
Exactly. And that's a primary cause of small intestinal bacterial overgrowth, or SIBO, which leads to bloating, gas, and poor nutrient absorption. You have to give the system time to clean the pipes between meals.
Okay, so stop grazing, let the janitor do his job. But what about what we're putting in during those meals? There's a really interesting section here called the liquid trap, and it focuses specifically on the sugar, fructose.
Fructose is a very unique and frankly tricky sugar. Glucose can be used for energy by pretty much every cell in your body, your muscles, your brain, your heart. Fructose, on the other hand, is metabolized almost exclusively by the liver. It's a significant burden on the liver.
So when I eat an apple, what happens?
When you eat a whole piece of fruit, the fiber in that fruit creates a kind of gel in your intestine, which slows down the absorption of the fructose. This gives your liver a chance to process it slowly over time.
But when I drink juice...
Drinking juice is like a fructose bomb hitting your liver. When you drink a glass of orange juice or apple juice, you are dumping a massive load of liquid fructose into your liver all at once. The liver gets completely overwhelmed. It can't possibly use all that for energy, so it does the only thing it can. It converts the excess fructose directly into triglycerides, which is fat and uric acid.
So drinking fruit juice is literally a direct instruction to my liver to start making fat.
Precisely. It is one of the primary drivers of non-alcoholic fatty liver disease, which we are now tragically seeing in children.
So the rule of thumb from the guide is, eat your fruit, do not drink it.
That's the golden rule. The fiber is the antidote to the fructose.
Now, we have to talk about seed oils. This is a huge controversial topic online right now, but the source material is very, very firm on this. Soybean oil, canola, corn, sunflower, safflower oil. Why are these considered the enemy?
It really boils down to structural integrity at the most fundamental cellular level. These industrial seed oils are extremely high in an omega-6 polyunsaturated fat called linoleic acid. Now, we need a tiny amount of this in our diet, but the modern diet is absolutely drowning in it. And this linoleic acid gets incorporated directly into your cell membrane.
So it becomes part of the outer shell of my cells.
Yeah. Yes, and even more critically, it gets incorporated into the membranes of your mitochondria, the little power plants inside your cells. The problem is that linoleic acid is extremely unstable. It oxidizes very easily. Think of it like trying to build the walls of your house out of dry straw instead of bricks.
It might work for a while, but it's not stable.
It's not stable. As soon as there's a spark, any kind of oxidative stress, the entire wall just catches fire.
And that cellular fire is what we call inflammation.
That is the definition of inflammation. It causes the cell to break down and become dysfunctional. The advice is to completely replace these unstable oils with stable, saturated, or monounsaturated fats. Things like butter, ghee, tallow, coconut oil, avocado oil, and olive oil. These are like building your cellular walls with bricks.
It's scary because I started checking labels since reading this, and seed oils are in everything. They're in oat milk, crackers, almost all healthy salad dressings. It's almost always sunflower or canola oil.
It's because they are incredibly cheap to produce, they're tasteless, and they're very shelf-stable, which is why the food industry loves them. Your mitochondria, on the other hand, do not love them.
Okay, one last point on nutrition before we move on. The glucose management hack. Let's say I'm going to eat carbs. I'm at a restaurant, I'm going to have the pasta, I'm going to have the bread. Is there a way to mitigate the damage?
Yes. The guide is very clear. Never eat naked carbs. The order in which you eat your food matters immensely. If you eat the bread basket first on an empty stomach, you get a massive, rapid glucose spike.
So you want to build a wall first?
You want to build a wall of fiber. The rule is to sequence your food. Fiber first, so eat the salad or the broccoli. Then protein and fat, the steak or the cheese. And then the carbohydrates last.
How does that help?
The fiber creates a physical mesh-like barrier in your intestine that physically slows down the absorption of the glucose and starch from the carbs. It's been shown to reduce the subsequent blood sugar spike by as much as 70%. It flattens the curve dramatically.
That is such a simple, actionable tip. Just eat your salad first. Okay, let's move down into the gut itself. Section 4 covers the gut, water, and minerals. The statistic here is just wild. We are apparently 90% bacterial by cell count.
By cell count, yes. We are essentially a vehicle for our microbiome. We're a walking hotel for trillions of bacteria. And the problem is we are constantly waging war on our own guests through over-sanitization. This is the hygiene hypothesis. We scrub everything with antibacterial soaps. We use hand sanitizer constantly. We stay indoors. We are starving our immune systems of the training data they need to function properly.
So you're saying we need to eat more dirt?
A little bit. We evolved in contact with soil. We need soil-based organisms. We need fermented foods like sauerkraut, kimchi, kefir. And honestly, the guide suggests you should stop scrubbing your organic vegetables until they're sterile. A little bit of the biome from the farm is actually beneficial for you.
Now, here is a myth that I have believed my entire life. Heartburn means I have too much stomach acid, so I get heartburn, and I take a Tums or an antacid to neutralize the acid.
That is one of the most pervasive and damaging medical myths out there. In most cases, heartburn and acid reflux are caused by having too little stomach acid, not too much.
Wait, how does low acid cause a burning sensation? That makes absolutely no sense.
It's a mechanical issue.
Yep.
There's a valve at the top of your stomach called the lower esophageal sphincter, or LES. Think of it like a drawbridge. That drawbridge is designed to close tightly when it senses a highly acidic environment in the stomach, to keep that strong acid down where it belongs.
So it's actually acid activated?
Yes. If your stomach acid is weak, which happens due to stress, aging, and nutrient deficiencies, the valve doesn't get a strong enough signal to close all the way. It stays slightly open or flaps open easily. So even though your acid is weak, it can splash up into your esophagus, which has no protection and is very sensitive.
And then we take antacids,
which neutralizes the acid even more. It might provide a minute of temporary pain relief, but you are making the underlying problem so much worse. You're basically telling that valve to stay open permanently. And without strong stomach acid, you can't properly digest protein, you can't absorb critical minerals like B12 or magnesium, and you allow pathogens to survive the stomach and get into your intestine.
So if you have heartburn, the solution might actually be to increase your stomach acid.
In many cases, yes. The supplement betaine HCl is often used to test this, but obviously you should check with a knowledgeable doctor first.
Okay, moving on to hydration. This concept of dead water. I drink filtered water. I've got a fancy reverse osmosis system at home. Is that actually bad for me?
It's good that you're removing chlorine and other toxins, but a reverse osmosis system removes everything. It removes all the beneficial minerals too. It creates empty water. Biologically, water follows minerals. That's the principle of osmosis. If you're drinking gallons of plain demineralized water, it doesn't necessarily get into your cells. In fact, it can leach minerals out of your body. You pee clear liquid all day, but your cells can remain chronically dehydrated.
So I'm just flushing myself out.
You're flushing out your electrolytes.
Mhm.
The fix is incredibly simple. You have to remineralize your water. Just add a tiny pinch of high-quality sea salt or Himalayan salt to your water.
Won't adding salt raise my blood pressure?
Not a tiny pinch. We're not trying to make ocean water here. Just enough to give the water the electrolyte structure it needs so your cells can properly absorb it. And this is especially important for your morning routine.
Okay, why the morning?
You lose about a liter of water every night just from breathing and sweating. You wake up dehydrated, and as a result, your blood is more viscous, it's thicker. If you hit that dehydrated system with coffee first thing in the morning, and coffee is a diuretic, you are putting a huge amount of stress on your kidneys and your heart. The protocol is very clear. Drink 500 to 700 milliliters of water with a pinch of salt in it immediately upon waking. Repressurize the whole system before you add the diuretic.
I've actually started doing this, the salt water first thing. And it definitely wakes you up faster than caffeine alone. It feels like you're turning the hydraulics back on in your body.
Because that is literally what you were doing.
Let's talk about the physical structure of the machine itself. Section 5, structural integrity. And we have to start by talking about the chair and this thing called fascia.
The sitting disease is a huge topic, but the real issue underneath it is fascia. I want you to think of fascia as a continuous, three-dimensional web of connective tissue. It wraps every single muscle, every organ, every bone in your body. It's like a single, seamless bodysuit that's underneath your skin. And it's not just packaging, it's piezoelectric. Piezoelectric. It generates a small electrical charge under pressure or stretch. It's a communication network. But here's the catch. If you stop moving, fascia dehydrates and it fuzzes over. Think of it like two pieces of plastic wrap. If you pull them tight, they're smooth. But if you crumple them up and leave them overnight, they stick together in a big knot.
So if I sit in a chair for 8 hours a day in the shape of an L,
Your fascia literally starts to cement itself into that L shape. Then you try to stand up, but your hips are still trying to sit down because the fascia has become short and tight.
and the ergonomic chair I bought is actually a trap. I paid extra for the fancy lumbar support.
The more support a chair gives you, the less your own muscles have to work. If the chair is supporting your spine, your deep core muscles, your postural muscles, they just turn off. They atrophy over time. The guide is a huge proponent of variable sitting. Don't stay in one position. And surprisingly, it recommends sitting on the floor as much as possible.
Like a kindergartner during circle time.
Exactly. When you sit on the floor, there's no backrest. You have to constantly shift your weight and engage your core just to stay upright. You're naturally stretching your hips in different positions. It's active sitting, not passive collapsing.
Before we move off structure, we need to talk about our feet. The guide uses the term foot binding. That's a strong phrase.
It is, but it's accurate. Look at a baby's foot. It's widest at the toes. Now look at almost every modern shoe, even athletic shoes. They come to a point. We are literally squeezing our toes together into a triangular box all day long.
We're binding them.
We're binding them. This completely shuts down the sensory feedback from the 200,000 nerve endings in your feet. It destabilizes the natural arch of the foot. And because everything is connected by that web of fascia, if your feet are dysfunctional, your knees will hurt, your hips will lock up, and your back will ache. The problem often starts at the ground.
The recommendation in the guide is for zero-drop shoes.
Yes, most modern shoes have a raised heel, even a standard running shoe. This artificially shortens your calf muscle and Achilles tendon, and it tilts your entire pelvis forward. Zero drop simply means the heel and the toe of the shoe are at the same level, which is our natural state. And a wide toe box allows your toes to splay out and function like they're supposed to.
So basically, we need to stop wearing casts on our feet all day.
That's a perfect way to put it.
And there's one stretch mentioned specifically to undo all the damage from sitting. The couch stretch.
It's the ultimate antidote to the chair. You put your back knee up against a wall or the front of a couch with your foot pointing at the wall, and then you step your other leg out into a deep lunge.
Oh.
It is excruciatingly painful if you sit a lot.
Oh, I know this one. It feels like your thigh muscle is going to snap in half.
That intense sensation is your hip flexors, your psoas muscle, begging for mercy. They have been stuck in a shortened position all day. Holding that stretch for just 2 minutes on each side every day can fundamentally change your posture and save your lower back.
We also need to talk about what's happening at the other end of the spine. Tech neck. The physics described here is genuinely terrifying.
It is. Your head weighs about 10 to 12 pounds. Think of it like a bowling ball. When it's balanced directly over your spine, it's fine. But when you tilt your head forward 60 degrees to look down at your phone, basic physics and leverage create an incredible amount of force. The effective weight on your cervical spine becomes 60 pounds
That's like carrying an 8-year-old child around on the back of your neck.
all day long. And the body, being an amazing adaptation machine, reacts to this constant stress by laying down extra bone to try and support that weight. That's how you get that dowager's hump, that hard bump at the base of the neck. It's a calcification from years of poor posture.
So what's the fix?
It's simple, but not easy. Phone at eye level. You have to raise the phone to your face. Don't lower your face to the phone. Yes, you look a bit silly holding your phone up high in public, but your spine will thank you. And the guide also recommends doing dead hang.
Just hanging from a pull-up bar.
Just hanging for a minute a day. It uses your own body weight and gravity to gently decompress the spine and undo all that compression.
Simple, free, and effective. Okay, let's move into section 6. This is where things get a little sci-fi, but also very scary. Environmental and cognitive hacking. We have to talk about receipts.
This is one of those invisible hijackers of our health. Thermal paper receipts, the shiny, plasticky feeling ones you get at the grocery store or gas station, are coated in a fine powder of either bisphenol A, BPA, or its equally problematic cousin, BPS. It acts as the color developer for the ink.
And the BPA isn't locked into the paper.
No, that's the problem. It's a free powder sitting on the surface. When you touch that receipt, it absorbs directly through your skin in seconds. And here is the really, really bad combination. Did you use hand sanitizer before you grabbed the receipt?
I do that all the time. Sanitize my hands, then grab the receipt. Hygiene.
You are making the problem exponentially worse. The alcohol and other surfactants in the hand sanitizer break down the protective barrier of your skin. It's been shown to increase the absorption of the BPA by up to 100 times. You are essentially mainlining an endocrine disruptor.
That is just wild. What does BPA actually do in the body?
It's a potent xenoestrogen.
Yeah.
That means it mimics the hormone estrogen in the body. It can block testosterone. It signals the body to store fat. And it can wreak havoc on reproductive health in both men and women. The advice from the guide is extremely strict. Just decline the receipt whenever possible. If you must touch it, hold it by the non-printed side. And always wash your hands with soap and water before eating.
I don't think I'm ever going to touch a receipt with my bare hands again. And since we're talking about invisible toxins, we added a section here on tap water. We talked about the lack of minerals earlier, but what about the bad stuff that's in the water?
This is an uncomfortable topic, but it's important. Municipal water treatment plants are designed to do one thing very well: remove bacteria and viruses. They are not, however, designed to remove dissolved pharmaceuticals.
Pharmaceuticals, you mean? Like
Yeah.
pills?
Yes. When people take medications like antidepressants, birth control pills, or antibiotics, their bodies don't fully metabolize them. They excrete small amounts. That goes into the sewage system, through the treatment plant, and then back into the general water supply. We're now finding trace amounts of synthetic estrogen and various antidepressants in tap water all across the country.
So we're all essentially microdosing other people's prescriptions every day.
In a way, yes. And while the individual levels are very low, the concern is the cumulative effect of drinking this water every single day for decades.
Does a standard Brita filter fix this?
Generally, no. A simple carbon filter can help with the taste and with chlorine, but to effectively remove dissolved pharmaceuticals, you really need a more robust system like reverse osmosis or a heavy-duty carbon block filter.
So filter your water aggressively, but then remember to add the good minerals back in.
Exactly. Clean the Kansas completely, then paint it yourself with the minerals you want.
Let's switch from the body to the brain. Cognitive performance. We all like to think we're really good at multitasking. I'm listening to a podcast, writing an email, and checking Slack all at the same time.
We are deluding ourselves.
Yeah.
From a neurological standpoint, true multitasking is impossible. The brain cannot consciously process two complex cognitive tasks simultaneously. What you are actually doing is rapid switching. You are just toggling your attention back and forth very quickly.
And what's the cost of that constant toggling?
Every time you switch, you leave behind what neuroscientists call attention residue. Part of your brain is still thinking about the email you were just writing when you move over to Slack. This has been shown to lower your functional IQ by about 10 points. That's the equivalent of being stoned. And it rapidly depletes the glucose in your prefrontal cortex. That's why you have crippling decision fatigue by 2 p.m.
So the fix is just single tasking.
Deep work blocks. The guide recommends setting a timer for 90 minutes and working on one single task. Phone in another room, all other tabs closed. You will get more high-quality work done in one 90-minute block than you will in 8 hours of distracted switching.
And what if you hit a wall? You're stuck on a problem and can't figure it out.
Move your body.
Oh.
There's a chemical called BDNF, brain-derived neurotrophic factor. Scientists call it miracle grow for the brain. It helps you grow new neurons. And it's released during aerobic exercise. If you are stuck, the advice is to walk to think.
Walk to think.
Yes, the optical flow of moving through space, seeing the world pass by you, actually helps to unlock cognitive rigidity. It literally helps you change your perspective and, therefore, change your mind.
I love that. Okay, Section 7 covers the silent systems. These are things we tend to ignore until they break. Let's start with the lymphatic system.
You have roughly twice as much lymph fluid in your body as you have blood. It's your body's sewage system. It's responsible for collecting metabolic waste from your cells. But here's the major design flaw. Unlike your blood, which has a massive, powerful pump, the heart, your length, has no pump at all.
So it just sits there. How does it move?
It relies entirely on muscle contraction and gravity to move. So if you sit still at a desk all day, your sewage system pools. It stagnates.
That sounds gross.
It is. And on top of that, tight clothing. Tight underwear, belts, skinny jeans can act like a physical dam, blocking the flow of lymph fluid.
So what's the fix? How do we manually pump the sewage system?
Rebounding. A mini trampoline.
Seriously, a
Yeah.
trampoline is the answer.
It is the single best thing you can do for your lymph. When you're at the bottom of the bounce, the G-force opens all the little one-way valves in your lymph vessels. When you're weightless at the top of the bounce, those valves close. You are physically pumping the fluid up through your system using gravity. Just 10 minutes a day is transformative.
And if I don't have a mini trampoline in my living room?
The next best thing is deep diaphragmatic breathing. The change in pressure in your chest cavity as you breathe deeply acts as a central vacuum pump for the lymphatic system.
Okay, let's talk about eyes again, but from a different angle. Optical mechanics. There's a direct link between how we use our vision and our stress levels.
A hardwired direct link. We essentially have two modes of vision. The first is focal vision. This is when you are staring intently at a screen or a phone just a few feet from your face. This mode of vision automatically triggers the sympathetic nervous system, your fight or flight response. It signals focus, threat, work.
And the other mode is panoramic vision.
Yes, that's when you're looking out at a horizon, softening your gaze, taking in your periphery. This mode triggers the parasympathetic nervous system. It signals calm, safety, and relaxation.
So when I'm staring at my laptop for 4 hours straight, I'm physiologically stressing myself out just by how I'm using my eyes.
Correct. You are locking your nervous system in threat mode for hours on end. The rule here is the famous 20-20-20 rule. Every 20 minutes, you need to look at something 20 feet away for at least 20 seconds. But the key is to really soften your gaze. Try to see the walls in your periphery. That panoramic dilation is what lowers your cortisol instantly.
And one more surprising thing on eyes, sunglasses. The guide says to avoid wearing them in the morning. That seems counterintuitive.
It does. But we're back to the importance of light signals. Your eyes need to sense some of the morning UV light to signal the production of melanin in your skin. If you wear sunglasses first thing in the morning, your brain thinks it's still dark outside. It doesn't send the signal to your skin to prepare for sun exposure.
So I'm more likely to get a sunburn later in the day.
You are paradoxically more likely to get sunburned because your skin wasn't prepped for the sun by the initial light signal that came through your eyes.
That is mind-blowing. My skin is literally listening to my eyes. Okay, let's go back to the mouth one more time. But this time, it's about blood pressure. This connection is bizarre.
It's that nitric oxide pathway again. You have a very specific microbiome that lives on the surface of your tongue. These bacteria have a special job. They convert nitrates from your food, from things like beets or arugula, into nitrites.
Okay.
When you swallow your saliva, those nitrites go into your stomach where the acid converts them into nitric oxide, which then gets absorbed, dilates your blood vessels, and lowers your blood pressure.
And then we come along and nuke them all.
With alcohol-based antiseptic mouthwash. If you use something like Listerine every day, you kill those beneficial bacteria along with the bad ones. Studies have shown that daily use of antiseptic mouthwash can significantly raise blood pressure within a matter of days because you've cut off your body's primary nitric oxide supply chain.
So ditch the harsh mouthwash. And while we're at it, the guide also has a strong opinion on fluoride in toothpaste.
It does. It recommends switching to a toothpaste that contains nanohydroxyapatite, or NHA.
Yeah.
It's a mineral that your tooth enamel is actually made of. It remineralizes and strengthens your teeth just as effectively as fluoride, but without any of the potential neurotoxicity risks that are associated with high fluoride ingestion.
All right, moving on to section 8, skin, vagus nerve, and longevity. Let's start with the acid mantle of the skin.
Your skin is not supposed to be neutral. It's supposed to be slightly acidic at a pH of about 5.5. This acid mantle is like the castle wall. It keeps moisture in and it keeps bad bacteria out. The problem is that most soaps are highly alkaline, a pH of 9 or 10.
So when we scrub our whole body with soap every day.
You are literally tearing down your own castle wall. You strip away that protective acid mantle. This leads to dry skin, eczema, and general irritation.
So we shouldn't be soaping our whole body.
Unless you were literally covered in mud, no. The guides suggest you only need to use soap on the bits and pits. The groin, the armpits, the feet. The rest of your skin has natural oils that are protective. Just rinse with water. And the golden rule for anything you put on your skin is, if you wouldn't need it, don't put it on your skin.
Because it goes straight into your bloodstream, right?
It does. It bypasses the liver's detoxification system.
Yeah.
Things like aluminum deodorants, chemical sunscreens, they get absorbed directly into your system.
Let's talk about the vagus nerve. This is described as the body's stress brake. How can we manually press that brake pedal when we're feeling anxious or overwhelmed?
The guide offers two really cool, simple hacks here. The first one is humming or chanting. The vagus nerve actually passes right through your vocal cords. The vibration from humming, or a deep om sound, physically stimulates the nerve and helps to calm your entire nervous system.
That explains why monks have been doing it for centuries.
It's ancient biohacking. The second one is the cold face reflex. If you're having a panic attack or you're just in a state of high anxiety, fill a bowl with ice water and submerge your face in it for 15 to 30 seconds.
That sounds jarring.
It is, but it's incredibly effective. It triggers something called the mammalian dive reflex. Your ancient brain thinks you are suddenly diving into cold water. It instantly slows your heart rate down to preserve oxygen. It is a powerful biological reset button for a panic state.
That brings us nicely to longevity science. Two big concepts here, hormesis and autophagy.
Hormesis is the fundamental biological concept that what doesn't kill you makes you stronger. The problem with modern life is that we are too comfortable. We need acute, short-term stressors to build resilience. We need the heat of a sauna to activate heat shock proteins, which go around and repair misfolded proteins in our cells. We need the shock of cold to activate our brown fat, which is a metabolically active tissue that burns energy.
And what about autophagy?
Autophagy literally means self-eating. It is your body's cellular recycling program. When it's activated, your cells go around and clean out old, damaged, junky components. But here's the key. Autophagy only turns on when your body is not in a growth state.
This is the MTOR versus autophagy balance.
Right. MTOR is the construction crew. It's the pathway that builds muscle and helps you grow. It's activated when you eat, especially protein, but it also accelerates the aging process. Autophagy is the cleaning crew. It can only work when MTOR is turned off, which happens when you are fasting.
So if you are eating and snacking all day long, the construction crew is always on site and the cleaning crew never gets a chance to show up.
Exactly. You might get big and strong, but your cells get filled with junk. You need to cycle between the two states, feast and famine, build and clean. That's the rhythm of life.
And finally, a really weird biomarker for longevity, grip strength.
This is one of the single strongest predictors of how long you will live and how well you will live. It's not just about having a firm handshake. Your grip strength is a direct measure of your neural drive, how well your central nervous system is able to recruit your muscles. If your grip strength is weak, it's a sign that your whole system is degrading.
So we should be training our grip.
The daily hang we talked about for tech neck is perfect. Hang from a bar for 60 seconds a day. It builds incredible grip strength, and it decompresses that shoulder joint we've been damaging with our phones all day.
We have covered so much ground. Let's try to wrap this up with Section 9, the no-fluff supplements. We aren't big on recommending pills, but the guide does list a few essentials, mainly because our modern soil is so depleted of minerals.
Essential stack. First and foremost, magnesium. Up to 80% of the population is deficient. But don't buy magnesium oxide. It's cheap and it's basically just a laxative. You want magnesium glycinate for sleep and relaxation, or magnesium L-threonate for brain health.
Okay, what's second on the list?
Vitamin D3. But And this is absolutely critical. It must be paired with vitamin K2.
Why is the K2 so important?
Vitamin D3 is great. It helps you absorb calcium from your food, but K2 acts like the traffic cop. K2 is what directs that calcium to go into your bones and teeth. Without enough K2, the calcium can end up being deposited in your arteries, causing calcification and heart disease. You do not want hardened arteries.
Third.
A high-quality omega-3 fish oil.
Mm-hmm.
You need a high dose of EPA and DHA to balance out all those inflammatory omega-6 seed oils we're getting in our diet. And finally, creatine.
Wait, creatine, I thought that was just for bodybuilders who want to get huge.
That's the old stereotype. But creatine is actually a primary fuel source for the brain. It helps your brain recycle ATP, which is the main energy currency of every cell. It has been shown to fight cognitive fatigue and is incredible for memory and mental performance.
And one last point, something about a collagen mismatch.
Right. This is the idea that ancestrally we would have eaten the whole animal, the skin, the tendons, the cartilage. That gave us a lot of an amino acid called glycine. Today, we mostly just eat muscle meat steaks, chicken breasts. Muscle meat is very high in another amino acid called methionine.
And that's bad.
A high level of methionine without enough glycine to balance it out is highly inflammatory and has been shown to accelerate the aging process. You need the glycine to balance the equation. You can get it from bone broth or by supplementing with collagen peptides or gelatin.
This has been absolutely exhaustive. My head is spinning, but in the best possible way.
It's a lot to take in. But the final truth of this entire manual is really powerful. The human body is anti-fragile. A car wears out the more you drive it. Your body is the opposite. It gets stronger and more resilient when you stress it properly. Exercise, fasting, temperature changes, these are the things that maintain order. Comfort is what causes decay.
There was a line in the guide that really stuck with me. Discipline is not a moral imperative. It is a biological requirement.
That's the key to the whole owner's manual. You have to drive the machine correctly, or it will break down.
Okay, that was the ultimate lightning round of biological optimization. We covered everything from sleep light and mouth taping to toxic receipts, dead water, the dangers of sitting on a chair, and the importance of hanging from bars.
A lot of fatal errors identified and hopefully corrected.
So I want to challenge everyone listening right now. Don't try to do all of this tomorrow. You'll go absolutely crazy. Just pick one.
Just one.
Are you going to tape your mouth shut tonight? Are you going to stop touching receipts at the store? Are you going to put a pinch of salt in your water first thing in the morning? Pick one thing.
Fix one error in your code. Then, once that becomes a habit, move on to the next one.
Start running the manual. Thanks for diving deep with us. We'll see you on the next one.